Hello, I welcome you all in this course on power plant engineering, and today we will discuss about the hydroelectric power plants. We have amply discussed about the thermal power plants, and now we will start discussions on hydroelectric power plants. Now, topic to be covered in the present lecture are: I will introduce you what is hydroelectricity, then advantages of hydroelectric power plants, how to select the site for a hydraulic power plant. Unlike thermal power plant, there are several restrictions on the site selection for a hydroelectric power plant, right? We will discuss a little about hydrology also, what is hydrology, and elements of hydroelectric power plants, what are different elements of hydroelectric power plants, and choice of dam, which sort of dam should be used for a particular location. We will start with the hydropower. Hydropower. First of all, hydropower is very cheap. It is cheap because here the working fluid is water, and water is available free of cost. Unlike thermal power plant we have to use coal, or nuclear power plant we have to use some nuclear fission material. Okay, the fuel cost is high, especially in nuclear power plants. But if you talk about the hydropower plants, we are using only water as a working fluid. Okay, so the fuel cost is almost nothing, or we can say cheap perpetual power. Right? It is possible that the plant is designed for a certain capacity, it is working on under capacity, but it will continue to work. It will continue to give you the power. Right? So, that is the main benefit of hydropower. Actually, in India, the electricity was introduced in 1779. It was introduced in Calcutta, and first this hydropower plant, it came into the existence in not 1779, 1879. This is not 1779, 1879. So, it was introduced in Calcutta. Regular electric supply started in 1881, and first this hydro plant was established in Darjeeling, which is in West Bengal, in 1897. And since then we have number of hydropower plants. We have Damodar Valley. Some of the famous plants are Damodar Valley and Bhakra. Bhakra is a concrete dam, right? And Hirakund, Nagarjun Sagar, and Rihand, and the latest one of Tehri Dam. So, these are a few names, but we have number of hydro power generation units which are established in the country. Now, how the power is generated in a hydro plant? It is simple. The potential energy of the water, a dam is made, and suppose the height of the dam is h. The potential energy of the water, right, which is coming from the bottom, suppose this level is maintained, because water is coming from behind. So, this level is maintained. So, the water which is leaving at the bottom will have high pressure, and this pressure will be converted into the kinetic energy, or pressure energy or the potential energy is converted into the kinetic energy. So, we get at the inlet of the turbine, there is a turbine, hydro turbine, there are different type of turbines from the steam turbine, right. So, in these turbines the water enters with very high velocity, right, and same thing happens here as happened in the case of steam. The turbines have blades, and energy is imparted to, kinetic energy is converted to exerts force, the change in the direction of the velocity of the fluid, or sometimes fluid directly strike the blade. Here in this case, in hydro turbines, sometimes what happens, it directly strike the blade also. So, the energy is imparted to the rotor. This is how the energy is imparted to the rotor, and the rotor starts the generator, and how the electricity is generated in a hydroelectric power plant. So, the potential energy is H rho g. H rho GH. So, rho H and G. This is the potential energy, right? And this potential energy is converted into, and there is some efficiency also which has to be taken into the account. So, there is potential energy is mgh. Potential energy is mgh. The potential energy in a hydropower plant is mgh, and this mgh is converted into the kinetic energy. Now, this mgh is nothing but rho q gh, because when we are dealing with the water, we always deal in terms of volumetric discharge. So, the volumetric discharge multiplied by rho, it may have some efficiency also. Normally, hydropower plants have efficiency in the range of 80 to, maybe it can go up to 92% or 94%. So, that is the efficiency of a hydropower plant. Now, nearly 20% of the power generation in the world, 20% of the power generation is hydropower generation. Some of the countries like Norway, Norway is a Scandinavian country close to the North Pole, or Switzerland, they have 100% hydro based power generation. They do not have any coal based plant or a nuclear power plant. So, the power generation is 100% hydro based. There is a beauty of hydro project that it is multi-purpose. It is multi-purpose. If you look at a thermal power plant, the sole purpose of the power plant is to generate electricity, right? Nowadays, fly ash, we are trying to make bricks or use the fly ash. Fly ash is also used in cement industries, and fly ash bricks also we are trying to make, so that the fly ash can be used, which is byproduct of thermal power plant. But regarding this hydropower plant, it has many uses. In addition to the power generation is one of the use. One of the major uses is flood control. Right? Flood control, because a reservoir is made. Suppose there is a water is coming from this side, a reservoir is made of water, right? When there is an excess of water, it can be stored in the dam. So, on the downstream, the flow rate can be monitored, but if the dam is full, sometimes the water has to be discharged irrespective of the fact there is plenty of water on the downstream side, right. So, this is a very good flood control instrument. Now, irrigation, right. Irrigation, because we can control the flow of water, right. So, dams are effectively used for the irrigation purpose in the mainland, right. So, this is another benefit of having hydro plant. This third one is power generation is there. Now, in addition to the power generation, the hydropower plants are also used for the pisciculture, where fish are grown. Okay. Now, we will go for the advantages and disadvantages of hydropower plants. First of all, biggest advantage is no fuel is required. No fuel is required in a hydroelectric power plant, and it is quite reliable. Efficiency of the hydroelectric power plant does not change with time. If you look at the efficiency of thermal power plant or any other power plant or any other machine, it deteriorates with time. But efficiency of the hydroelectric power plant in general does not vary with time. I mean, it is, though if you operate a plant for a very long time, it will change. But the time dependence of the efficiency of the hydropower plant is the least, we can say. Low running cost, because less maintenance is required. Hydroelectric power plant does not have something like boiler, condenser, less machines are there. Only there is a dam, head race, tail race, water comes from the dam, it exerts on the turbine and it goes out from the tail race. So, minimum number of equipment is there, minimum maintenance is required. So, running cost is also low for hydroelectric power plants. Ash problem is not there, because if you go for the nuclear power plant, then nuclear fuel disposal problem is there. If you go for thermal power plant, then ash problem is there, right. But it does not have any ash problem, and it's a clean energy, clean renewable energy. Pollution free, though it has impact on the environment, because where the hydroelectric power plant is constructed, it affects the flora fauna of the surroundings, right? But when the plant runs, during that time there is no pollution to the environment, so it is pollution free. So from hydroelectric power plants we get pollution free renewable energy, okay, at low running cost. On off is very easy. If suppose we have to start a thermal power plant, so thermal power plant you will have to first prepare the water for the boiler, feed water for the boiler, and then you run the boiler. Start up a boiler will take some time. For a huge, I am talking about a large power plant. Then it will go to the steam turbine. Steam turbine immediately it will not start. Some priming will be there, so it will take a lot of time. But in hydroelectric power plant, switch on and switch off is easy. Simply you have to supply the switch, just open the gate, water will enter the turbine and turbine will start producing water, right. So switch on and switch off is easy for the hydroelectric power plant, and it is a self-contained unit, right, and less skilled manpower is required. Less skill power, because if you operating a thermal power plant, say boiler operator is required, boiler operator has to be a certified boiler operator. So number of operations are there, but in hydroelectric power plant, less skilled labor can also be can also work for the hydroelectric power plant. Life is longer, life expectancy is 50 to 100 years, right. For thermal power plant it is typically 30, 35 or 40 years. Same is the case with the nuclear power plant. So life expectancy is high for a hydro power plant. It is robust structure, that is why the maintenance is low running cost and low maintenance, because it is robust. And the turbine runs, they run on, let us say, 300 to 400 RPM or 450 or 500 or not more than that, right. If you go for the steam power plant, or in that case the RPM is 3000 to 4000. RPM is high. When the RPM of the shaft is high, wear and tear will be more and maintenance will be more. Same is the case with the nuclear power plant, because the nuclear power plant only generation of steam is different from a normal thermal power plant, rest of the cycle is same. It also works on the Rankine cycle. So in hydropower plants, because the RPM is low, how we are managing with our low RPM, that is the reason being the density of the working fluid is high. In steam power plant we are using steam, in nuclear plants we are using steam, but in hydro plants we are using water which has 1000 times higher density, more than 1000 times higher density than steam, right. So these are the certain advantages of hydro. Second thing is, it is quick to response also. If there is a change in load, the hydro plant is quicker in response. Now if we talk about the disadvantages, disadvantages are, first of all, high capital cost. Because a lot of civil work has to be done in making a hydro power plant, so it has very high fixed cost, very low running cost, right. So the capital cost is high and we do not get return on that capital cost, though power generation is cheap, but it cannot compensate the high capital cost which has been made initially. So that is the one disadvantage. Second is, the power generation depends upon the quality of water. In rainy season, suppose a lot of mud is coming with the water, that mud may damage the turbines. So those days the turbines are not operative, right. So it depends, the power generation depends upon the quality of the water as well. Site selection is very typical. Anywhere you cannot establish a hydro power plant, so there are certain guidelines for the site selection. Those guidelines have to be followed before going for any site. So site selection is typical. Erection time is quite long. Normally it is said 10 years, but in our country it goes, say let us take example of Tehri Dam. It started in 1972, I think 1972 or 1973, and it finished in late 90s. It took around 35 to 40 years for Tehri Dam for the construction to be completed, right. Erection time is quite high and during that time the cost escalation is also there. Due to inflation, cost escalation is also there. And the last one is it disrupts the ecology of the area. That is the main disadvantage of a big hydropower plant. Now people say that instead of a big plant, we can go for a number of small plants or runoff plants. But the issue is, if you compare, I mean, a large number of small roads cannot replace a broad road or a highway. Similarly, if you put, small capacity plants, they have their own advantages, but the large dam, but they cannot replace the advantages of a large dam, right. So, and it depends upon the site also. Sometimes many things which are not in the hands of designers, it depends upon the dam site also, right. So, sometimes what happens, the dam size is the site is such that we can only go for the large dam, we cannot go for the smaller size of dam. Second thing is, especially in our country, the rainfall is only for a short duration of time, maybe 2 months or 3 months time. So, we do not have any uniform flow in the river. The rivers, they do really get dried up during the summer season. So, huge water is, reserve is required for hydropower generation, right. Now, if you mix hydro and thermal, so mix load sharing type of system is very suitable for our country. Suppose we mix hydro and thermal. I mean, part of the load is through hydro and part of the load is through thermal, and the ratio is, let us say, 13 to 70. That is a good mix which is happening in India, and we can go, it is not very rigid, we can go 35 to 65 also, right. So, this is known as power mix. So, base load, one type of plant, let us say hydro plant, it will take the base load, right, and the excess load can be taken care of the thermal power plant, something like this. So, it gives very high utilization, such type of arrangement, it can give a very high utilization factor for hydropower plants. Now, let us come to the site selection. Site selection. It is not an easy job, as I said earlier, right, and we have to do the hydrological, topographical and geological survey first. When we are going for a site, we should ensure what is the nature of the water which is flowing on the site, what is the flow rate, and what is the duration through which, and I mean, for each month, what is the flow rate. We will discuss about the hydrology later on. I mean, what is the annual flow rate pattern in a particular site, right. This has to be ensured, right. Topography of the site, whether it is a flat plain or a gorge or a narrow, or is a confluence. Best part is the confluence of two rivers. Normally, it is recommended that the dam should be made at the confluence of two rivers, because here you will get a narrow passage where you can build a wall or some rock fill. Well, there are different type of dams also. For example, Tehri Dam is a rock fill dam, and then a reservoir can be made. Geological report is also important. The nature of the soil and nature of the rock. The rock should be seasoned rock. It should not be a sort of rock which is not able to sustain the pressure of the water. So, such type of analysis has to be done, because if something happens in a hydropower plant, the downside plains will be completely flooded, right. So, in order to avoid that, first of all, these three surveys have to be done. So, an adequate water supply, it is important. Adequate water supply to the hydropower plant is important, and how much silt is coming into the water, because if the siltation is there in the hydro plant, then it will fill the reservoir and the capacity will automatically get reduced. Okay, and the availability of the water head will decide how much power can be generated and which sort of turbine can be used in a hydroelectric power plant. Second thing is accessibility to the site. Site should not be in a far off place where accessibility is difficult, right? Accessibility to the machines, accessibility to the human being, because labor has to be transported, machine has to be transported to the site. So site accessibility of site is also very important, right? Load, power generation and load send, this distance is also important because transmission losses are always there, right? So in order to reduce the transmission losses, this power generation point should not be far off from the location of the load, right? So we have to make a compromise. I mean, we cannot go absolutely close to the load, because on the load you will not find other things. So a good compromise of all these factors is necessary for a hydroelectric power plant. The land, as I said, geological survey has to be done, geological survey of the land has to also be done at the site, because everything has to be in order, only then we can go for a hydroelectric station at the particular site. And there are environmental and sociological aspects also. So because when a reservoir will be made at the site, and when the reservoir will fill, some part of the land will be submerged. Suppose there is a valley, right, and we have made a dam here. So the part of the, I mean, this land will be submerged, and normally if you go to the hilly area, the population lives in the valley only, right. So they have to be rehabilitated. There is a sociological aspect of making a dam. So and rehabilitation is a big problem. Rehabilitation is a big problem because people love the place where they are born and brought up, and when we try to rehabilitate them, there are many aspects which I mean prevent them from moving from that place, right. So this is about the site selection. Now we will discuss a little about the hydrology. So hydrology is a science which deals with rainfall, and runoff. Suppose in a river, the water is flowing. During that course, the water also gets evaporated, right, and sometimes the seepage is also there, right. So there is a mass balance of water has to be done. First of all, mass balance of water. Now before the mass balance, what exactly happens when the water flows in the river? It goes to the sea, where it gets evaporated, right, the clouds are formed, and the clouds they come back to the mainland where precipitation takes place, and this cycle keeps on going. So in hydrology we take into the account of environmental aspects also, right, and hydrology is used for irrigation, flood control, hydro project, water supply, and navigation, right. Now if you do the mass balance, then first is runoff, water is flowing in the river, plus seepage, plus evaporation, plus transpiration. Transpiration means the water is sucked by the plants and subsequently it is evaporated to the atmosphere. That is known as transpiration, is equal to precipitation plus minus storage. Now runoff, there are several units to express the runoff. If you use the SI unit, it is meter cube per second. It is also expressed meter cube per hour or centimeter cube per second. It depends, I mean, upon the, I mean, the person who is presenting the data, right. So, hydrographs are made, hydrographs. Now, how the hydrographs are made? For every month, let us start from January, February, March, April, May and so on. There is certain flow rate. January flow rate is so let us say 100 units. For February it is, let us say 200, then 500, then 300, then 100 and something like that, right. So, we will make hydrograph. This is January, Feb, March and so on, and this is the flow rate. So, 100 Jan it is 100, Feb it is 200, this is 200, this is 100, this is 300, 500, 200 and then it is 500, then it is 300, January, Feb it is 200 and then March 300 and then March, April, sorry, January 100, Feb 200, March 500, April 300 and so on. We can have a graph which is known as hydrograph. There is another curve which is known as flow duration curve. And the third curve is mass curve. Now, flow duration curve is it is a cumulative curve. For example, we will say that 100% flow rate for 100% time, let us take these 5 months. 100% time the flow rate is 100, 100 is 100% time. Then we will find for how much time duration the flow is 200 continuously. For how much time flow rate is 500, it is minimum, I think, that is only 1 by 5, 1 by 5 into 1 by 5 into 100, 20% time. 20% time we are getting flow rate 500, 100% time we are getting flow rate 100%, right. So, this is known as flow duration curve, for how much duration a particular minimum flow is ensured, right. And the third one is mass curve. Mass curve is a cumulative curve. First month 100, second is 200. So, first 2 months is 300. Now, third month is 500. So, first 3 months is cumulative value 5 to 7 and 800 like this, right. Okay. So, this is known as mass curve of any flow. After this, now we will come to the main elements of hydro plant. Main elements of the hydroelectric power plants. First is catchment area. It is the upstream area. Suppose the dam is made here. It is the upstream area which is across which the dam is constructed. So, that area, the waterfall in that area along with the upstream flow of the river will be stored in the dam. So, that area is known as catchment area. It is characterized by the size. What is the size of the catchment area? What is the shape of the catchment area? How is the surface of catchment area? What is the orientation of catchment area? This is how it is characterized. Another thing is reservoir in a hydroelectric power plant. The reservoir is the main body of any hydroelectric power plant where water storage of water takes place. So, if the runoff is something like this, if only a particular month the runoff, I mean high flow rate is there, otherwise flow rate is less, or there is a seasonal rainfall, huge reservoir will be required. If throughout the year there is a constant flow, almost constant flow of water, less capacity of the reservoir will be required, but this reservoir is the main part of any hydropower plant. And there is a dam. Dam is used for holding the water in reservoir, okay. And there is a thick wall, it may be made of RCC, it may be earth or masonry dam. It can be masonry dam, right. And after the dam there is a head race through which water goes to the turbine. Here is a turbine. So, there is head race, from head race water flows to the turbine. Here transmission of energy from fast flowing water to the shaft of the turbine takes place, and there is a tail race, and tail race, from tail race the water joins the main stream, right. A draft tube is also provided in some of the turbines. Draft tube is also provided to extract more energy from the flowing water, okay. There is a spillway also. Suppose there is a overflooding of reservoir, right. So, there is a spillway also to bypass the water, right, so that a particular level in the reservoir is maintained. That is all for today. Thank you very much.